force acting onto this particle which is moving along this very path. So force will be given to as equal to minus times m omega square, or this will be the force applied onto this body. But we have to calculate what kind of nature, what kind of nature of the force is, what kind of force is applied onto this very particle. So we have to discuss the nature of force F. So for that we will apply the curl upon this force, evaluating curl. You might have already done this very thing, curl of force. These are all simple problems. So curl upon this, what does curl is represented as delta cross F, and delta means in one dimensional motion, delta is equal to d something by with respect to x, that is the differentiation of that very quantity with respect to x. In two-dimensional it is dx by dt plus dy by d of something by dy, that is differentiating with respect to x and then again differentiating with respect to y. And here in case of this we have to say, for example, we have three-dimensional case, and the curl in three-dimensional is given to be equal to, these are vectors, I along x-axis, j along y-axis, and k along z-axis. What is the I component of this very delta? It is partial by partial x, that is differentiation with respect to x. Along y-axis it is differentiation with respect to y, and along z-axis it is differentiation with respect to z. This is the determinant of this very thing. What is the force component along the x-axis? Okay, we have given this very thing minus m omega times omega square times r, and r is this very thing. Fine. So r has only two components. Along x component is, along this very component is a cosine of omega t, and along y-axis, so here I will be writing f will be equal to minus omega square r. R is equal to omega square r is equal to a cosine of omega t along I-axis plus b sine of omega t along j-axis, that is y-axis. So we have two components. This is constant, say it is some constant a, this is also constant, this is also constant. So we have actually the two factors here. One is cosine component along x-axis, and another is sine component along j-axis, that is y-axis, and the third component along the z-axis, that's also missing, that is 0 along k. Fine. So we will be getting some constant, say here it is some star constant times cosine along the I-axis, which is this very thing, cosine omega t, plus some constant along the y-axis, that is sine omega t, and along j-axis, along k-axis, that is the z-axis, it is 0 because it is absent here. So in short, what will be the curl of force? Curl of force, that is, this will be equal to along I, along j, along k. It is partial differentiation with respect to x, partial differentiation with respect to y, partial differentiation with respect to z. Here the component is some constant, say a prime cosine omega t. Along the y-axis it is b prime sine omega t, and along k-axis it is 0. And we know the determinant, calculation of determinant, it is done as along this very row, keeping this very row as I hat, then deleting these very two, deleting this and deleting this, then cross multiplying this very thing. So partial differentiation of 0, this will 0, it will vanish, minus partial differentiation of, that is dz by d partial by partial z of b sine omega t, okay, minus j-axis. Now keeping this very thing deleted, this deleted, then cross multiplying this by this, cross multiplying this by this, so we'll get partial by partial x of this very 0 term, it will vanish, again no meaning of this, minus dz by this very thing, that is partial by partial z of a prime cosine omega t. Similarly with the k term, keeping this very deleted, we will get this multiplied by this, that is partial x of b prime sine omega t minus this very thing partial by partial y, that is differentiation of a prime cosine omega t with respect to y. Hope you are getting this. Along the k axis we will delete this very row and this very row. This is the rule of determinants. So differentiating with respect to x, this will act upon this very quantity b sine omega t, then differentiation with respect to y upon cosine of omega t, which I wrote here. But this is independent of z, as we see that cosine omega t and sine omega t, these are not the functions of x, y and z, because here omega and t are contained. It's a function of time, it's not a function of x nor y nor z. So these are all functions of time, not the functions of the Cartesian coordinate x, y and z. So this will be 0, this will be 0, because differentiation of constant will be 0. This will be 0, this will be 0, and this will also be 0. So that means the whole curl of the force will vanish. Okay, that means the curl will be curl of f will vanish. What does that mean? And this is the mathematical formulation of conservative force. Mathematical form of conservative force, that is if the curl of the force is vanished, that means the force is diverging. It is not curling, okay? It is not rotating. It is not curling around the point particle. Okay, that means the curl is vanished. That means it gets diverged. It is like this is the point particle here. The force comes out like this. This means the force is diverging. If it would have been like this, then there might be some curl present inside a particle. So that means the curl of the force is vanished. That is the mathematical formulation of the conservative force. That means the force is conserved. That means the force which we were discussing along the sinusoidal path, along the curve, which was given by r equal to cosine of omega t and sine of omega t, that very force is actually the conservative force. That means the work done by this force will be independent of the path. That is the outcome of this conservative force of the path it follows. That means the force which we were discussing here, it is conservative in nature, that is the curl of the force vanishes. Okay,